In Chapter 5, we're starting to talk about a type of expression called polynomials. So we'll build up to what polynomials are, but first I want to review when we have an expression, we're adding the various parts of that expression together. The individual things that we're adding together we call terms. So this right here, this expression, the 5x squared plus 2x plus minus 3 rather, 5x squared is one of the terms, 2x is the second term, and negative 3 is the third term. Now notice I just want to draw your attention to the fact that this third term is negative 3, not positive 3. It's because when I'm looking at this, I want them to be added together. So I'm really thinking of it as 5x squared plus 2x plus a negative 3. So that negative 3 is the third term. So in order to build up to polynomials, we're going to start off with the individual parts of a polynomial. We call the individual terms in a polynomial we call monomials. So a monomial is what we get when we take a constant or a constant times one or more variables. So for instance, we have a few examples of monomials down here. This 12x to the sixth. This is a constant times a variable. Well, it's raised to the sixth power, but this is, you can think of as just 12 times x times x times x times x times x times x. So we're multiplying it by one or more variables. We're multiplying it by 6 variables here, the same variable 6 times. 10 is also a monomial because it's just a constant. This 3x to the fifth y squared is also a monomial. This one we would basically think of this x being 5 different times and the y being twice. So 3 times x times and so on times y times y. This one right here is not a monomial because it's not multiplied by, I mean, we haven't even seen what negative exponents are, but in general, negative exponents don't work when we're talking about monomials. Fractional exponents don't work, and, well, again, fractional exponents don't work. So these are not monomials. But these ones over here are. This one's a monomial, this one's a monomial. All 4 of those are monomials. This one right here is also a monomial, it looks like. 1/2 times x to the fourth, that's 4 copies of the x, 2 copies of the y, and 1 copy of the z. So that would also be a monomial, but these 3 were not monomials. Alright, so now that we kind of have an idea of what a monomial is, let's see, when a monomial has only one variable, you can find its degree by just taking whatever that exponent is, by reading the exponent. So this one right here, let me erase this. This has a degree of 6 because the exponent, it essentially has 6 different variables occurring here. This variable occurs 6 times, so we would say it's degree 6. This one doesn't have any variables, so we would say it has degree 0. It doesn't have any variables at all. This one right here, well, let's see, these ones, when a monomial has multiple variables, what we do is, again, we're just counting how many variables there are. So there's 5 here and there's 2 there. There's a total of 7 variables here. If we were to kind of write it all out, this is a degree 7 monomial. So we'd say add by adding the exponents. Let's see, this one right here, we have 2 copies of the x and 1 copy of the y, so this is degree 3. Let's see, this one right here is degree, well, we have 4 for the x, 2 for the y, and 1 for the z. 4 plus 2 plus 1 is 7. That is a degree 7 monomial. The actual meaning for the degree, we're not really going to be using the meaning of the degree or why it's important very much for the purposes of this class, but usually what it has to do with is kind of what we generally call the tail behavior. So these have multiple variables in them, but if you look at with just a single variable, I'm going to think about those. 12x to the sixth, this kind of tells me what how quickly this grows as x starts to get large. As x starts to get large, we're raising it to the 6th power, and so it starts to grow at a particular rate. This one, if both x and y are getting large, it's essentially, you know, I kind of think of it as something to the 7th power. There's 7 different variables, and so this one would actually grow a bit faster than that one right there. This one would not grow nearly as fast because it would be only taking something to the 3rd power. If I was to plug in 100 for both x and y here, I'd get 100 cubed, versus up here, if I plug in 100, I'd get 100 to the 6th, versus if I plug in 100 here, I'd get 100 to the 7th if I plugged in for both x and y. So you can say I get much larger numbers if my degree is larger, and that's really the essence of what the degree is referring to. Again, we don't really need to know why we use the degree or what it really means for this class, but there's enough people that I think it's useful to see why it's used, even if we're not explicitly going to be using it.